studies to analyze rock formations.
Hi everyone and welcome to the show. Today we're diving into the world of natural gas processing. Think of raw natural gas like a diamond in the rough. It's full of potential but needs refining before use. We'll explore the steps from separating impurities to ensuring the gas is safe and efficient. Discover the science and engineering behind natural gas processing. Let's get started. Our journey begins with raw natural gas, fresh from the well. It's a mix of gas, liquids like water and heavier hydrocarbons, and even solids like sand and rock. To clean things up, the gas first goes through separation tanks. These tanks use gravity to let the heavier stuff settle out. Next, filters trap any remaining solids. Finally, scrubbers use special liquids to capture tiny particles, leaving us with much cleaner gas. Now that we've removed the solids and extra liquids, it's time to tackle water vapor. Water in natural gas can freeze and clog pipelines and corrode equipment. We use a process called dehydration, often with glycol that acts like a sponge, soaking up unwanted water vapor. Another method is using solid desiccants, like those silica gel packets in shoeboxes, but on a larger scale. This ensures our gas is dry and safe for transport. Our natural gas is getting cleaner, but it still has acidic gases like hydrogen sulfide and carbon dioxide. To sweeten the gas, we use a process called amine treating, which captures those acidic gases. This process removes most of the stinky stuff, making the gas safe and pleasant to use. Often we follow up with physical absorption using materials that soak up any remaining traces. This ensures our gas is free from corrosive and smelly components. Remember those heavier hydrocarbons we separated out? Some, like ethane, propane, butane and pentane, are valuable natural gas liquids or NGLs. To extract these NGLs, we cool the gas down, causing them to condense into liquid form. Another method is absorption, where a special oil absorbs the NGLs. These NGLs are then separated and used for various purposes. Think of propane, it fuels our grills and some homes. And there you have it, our natural gas has gone through a rigorous cleaning process. It's free of solids, liquids, acidic gases, and valuable NGLs have been extracted. What's left is a clean, efficient, and safe source of energy. This pipeline quality gas is carefully monitored to meet strict quality standards. It's then compressed to help push it efficiently through pipelines, reaching homes, businesses, and power plants. And there you have it. The essential steps in natural gas processing. We've seen how raw natural gas transforms into a clean and efficient energy source. It's a testament to human ingenuity and our ability to harness the power of nature. Natural gas processing plays a vital role in our everyday lives, providing us with the energy we need. You ever wondered where gasoline for cars or plastic for your toys comes from? Well, get ready for an awesome adventure as we explore the world of crude oil refining. Crude oil is like Earth's hidden treasure, a thick black liquid found deep underground. It's super important because it's the starting point for so many things we use every day. Think of crude oil as a magical mixture. Just like you can separate the different colors in a rainbow, we can separate crude oil into all sorts of useful stuff. This process is called refining, and it happens in giant factories called refineries. Ready to explore a refinery? Let's go! Our first stop is the desalting unit. Imagine trying to bake a cake with dirty tools. Yuck! That's why we need to clean crude oil first. Salt, water and other yucky stuff get removed in this stage. It's like taking a bath to get squeaky clean. Next up is the distillation tower, the heart of the refinery. Picture a giant tower with different levels, like a skyscraper for liquids. Here, crude oil is heated until it turns into vapor, which then rises through the tower. Different parts of the oil become vapor at different temperatures, so they separate out at different levels. It's like a race where everyone has different speeds. Now that we've separated the crude oil, it's time to make it even better. The heavier parts of crude oil are still pretty thick and gooey, but don't worry, we can use a cool process called conversion to break them down into smaller, more useful molecules. It's like chopping up a giant pizza into bite-sized pieces, but wait, there's more. We also need to remove any unwanted ingredients that can be bad for our environment. This is where the treating process comes in. Special units remove things like sulfur, making the fuel cleaner and more efficient. It's like giving our fuel a refreshing drink of water. Congratulations, science explorers. We've reached the end of our refinery journey. We've seen how crude oil is transformed into gasoline that powers cars, diesel that fuels trucks, and even jet fuel that sends airplanes soaring through the sky. But that's not all. Crude oil also plays a part in making plastics for your toys, clothes, and even your smartphone. It's amazing how something that started as thick black liquid can become so many incredible things we use every single day. So next time you hop in a car or play with your favorite toys, remember the amazing journey of crude oil and the science behind it. Petrochemical production is a critical process that transforms raw hydrocarbon feedstocks into valuable chemical products, serving as the backbone for industrial and consumer goods. The downstream sector focuses on refining, processing and converting hydrocarbons into olefins, aromatics and polymers, which are used to manufacture plastics, synthetic fibers, rubbers and countless other materials.
First, the ethane has to be recovered from the natural gas. The gas is cooled to -100 degrees Celsius, the temperature at which ethane condenses, making it easy to recover.
Why do 100% of petrochemical processes rely on purified feedstocks? The answer lies in the details of feedstock preparation. The journey of every petrochemical product begins with feedstock preparation. These feedstocks, derived from crude oil or natural gas, include naphtha, natural gas liquids, or gas oil. But before they can be transformed into the plastics, fuels and chemicals we use daily, they need to be purified. Imagine feedstocks as raw ingredients in a recipe. Just as you wouldn't want unwashed vegetables in your salad, petrochemical processes require clean feedstocks. This means removing impurities like sulfur, nitrogen, and heavy metals. Why is this purification so critical? These impurities can poison catalysts, corrode equipment, and cause environmental harm. By purifying feedstocks, we ensure that the downstream processes run smoothly and efficiently. The purification process typically involves several steps. First, distillation separates components based on boiling points. Next, hydrodesulfurization removes sulfur compounds. Other treatments strip away nitrogen and heavy metals. The result? Clean, high-quality feedstocks ready for the next stage of petrochemical production. Without this vital step, the entire production chain would be compromised. So next time you use a plastic product or fuel your car, remember the meticulous effort that goes into purifying the raw materials. Stay tuned for more insights into the fascinating world of petrochemicals. Steam cracking is a high-temperature thermal process where large hydrocarbon molecules are broken down into smaller, more valuable olefins such as ethylene, propylene and butadiene. The process begins with naphtha, a liquid hydrocarbon mixture, entering a cracking furnace. Inside the furnace, the naphtha is heated to extremely high temperatures, typically between 800 to 900 degrees Celsius. This intense heat causes the hydrocarbon bonds to break, resulting in the formation of smaller olefin molecules. These olefins are then separated and purified for various industrial applications, where it's heated to temperatures as high as 950 degrees Celsius. This intense heat is crucial for breaking down the complex hydrocarbon molecules into smaller, more manageable fragments. The process, known as thermal cracking, is essential in the production of various fuels and chemicals. By applying such high temperatures, the molecular bonds are broken, resulting in the formation of simpler compounds that can be further processed and refined, forming olefins. The output is cooled and separated in fractionation towers, which are crucial in refining processes. These towers play a vital role in producing the essential building blocks for numerous industrial applications, including fuels, lubricants, and petrochemicals. By efficiently separating different components, fractionation towers ensure the purity and quality of the final products, making them indispensable in the chemical and oil refining industries. Polyethylene, one of the most widely used plastics, is produced through polymerization. Ethylene gas enters a reactor, where a catalyst initiates the chemical bonding of monomers into long polymer chains. The molten polymer is then cooled and cut into pellets, which are packed and distributed for industrial use, forming the base material for countless plastic products.
Let's get back to the process. The purified ethylene is pumped into a reactor, where it is mixed with butene. A catalyst is then sprayed in the reactor, causing an astonishing reaction. The molecules bond to form a long chain, changing from a gas to a solid. This long chain of ethylene molecules is what's known as polyethylene. The butene is added to obtain the required stiffness and impact strength. The polyethylene comes out of the reactor as a white powder. To make it easier to transport, Total processes the powder into plastic pellets. This takes place in an extruder, where the powder is melted, mixed, and cut.
Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule.
I'm sure you've heard the news. Benzene, toluene, and xylene are in everything from paints to synthetic fibers. But how are they made? Let's find out. Aromatics like benzene, toluene, and xylene are produced through a process called catalytic reforming. It all starts with naphtha, a light hydrocarbon mixture, entering a reformer unit. Inside, the naphtha is heated to high temperatures and mixed with a catalyst, usually platinum. This heat and catalyst combo works wonders, transforming the aliphatic hydrocarbons in naphtha into aromatic compounds. Imagine it like a chemical makeover. The result? Benzene, toluene, and xylene, essential chemicals for everyday products. These aromatic compounds are vital for making synthetic fibers, paints, and many other industrial products we rely on. If you're a science enthusiast, you'll love learning how tiny molecules transform into the materials we use daily. Polymerization is like a molecular Lego set, where small building blocks called monomers, such as ethylene or propylene, join together to create something much bigger and more useful. Imagine these monomers as single bricks. Now, with the help of catalysts, these bricks break their double bonds and snap together, forming long chains known as polymers. There are different ways these chains can form. Linear polymers like polyethylene create flexible and lightweight materials perfect for plastic bags. But when these chains start to branch out or cross-link, we get polymers with different properties. Take polypropylene. Its semi-crystalline structure makes it sturdy, ideal for containers and even automotive parts. The beauty of polymerization lies in its versatility. By tweaking the type of monomers and the polymerization process, we can create a wide array of materials, each with unique characteristics. From the plastic wrap that keeps your food fresh, to the durable parts in your car, polymers are everywhere, making our lives easier and more convenient. So next time you use a plastic product, remember, it all starts with some tiny molecules and a bit of chemical magic.
Curious how crude oil shapes your world? Let's transform that curiosity. From raw hydrocarbons to essential materials, the downstream petrochemical production process transforms natural resources into the foundation of modern life. This innovative industry drives advancements in technology, sustainability, and industrial efficiency. Plastics, synthetic fibers, packaging, they're all born from this fascinating process. Petrochemicals, shaping our world one molecule at a time.
Petrochemical refinement begins with crude oil, which is processed in large refineries. The goal is to separate crude oil into useful fractions and convert them into valuable products. First is fractional distillation, where the crude oil is heated to high temperatures and sent into a distillation tower. Inside, the oil separates into components based on their boiling points. Lighter fractions like gasoline and naphtha rise to the top of the tower. Heavier fractions like diesel and residual fuel oil remain at the bottom. Next, we have cracking, where large hydrocarbon molecules are broken down into smaller, more useful ones like ethylene and propylene. These are essential for producing plastic and other materials. Next process is reforming. Reforming transforms lower value hydrocarbons into higher value fuels like gasoline by using catalytic or thermal methods to enhance their octane ratings. Reforming mainly divided into catalytic reforming and thermal reforming. Blending is a process that ensures the final petroleum products meet specific quality standards and performance requirements. It combines different crude oil streams to achieve specific properties like octane, viscosity, and emission standards, ensuring fuels like gasoline, diesel, and jet fuel. Treating focuses on removing impurities such as sulfur and contaminants through processes like hydrodesulfurization and sweetening, ensuring cleaner, more efficient fuels that comply with environmental regulations. Once oil and gas are extracted and refined, they must be transported safely and economically to consumers and industries worldwide. In this segment, we'll explore the primary methods used for transporting oil and gas. Pipelines are the most efficient and widely used method for transporting oil and gas over long distances. Pipelines form an extensive underground and underwater network that spans thousands of kilometers. They are designed to transport crude oil, natural gas, and refined products like gasoline and diesel. Alternative transport methods play a crucial role when pipelines aren't feasible. Firstly, the tanker ships. These massive vessels transport oil and liquefied natural gas across oceans. Tanker ships are essential for international trade, connecting oil-producing nations with global markets. In the oil and gas industry, consumer and industrial users of refined petroleum products play a critical role in our daily lives and global economy. Refined products like gasoline fuel transportation, powering everything from personal vehicles to commercial fleets, ensuring smooth and efficient travel. Diesel is essential for industries, powering heavy machinery, trucks, and equipment used in construction, agriculture, and manufacturing. Additionally, jet fuel supports the aviation sector, enabling safe and efficient air travel. Beyond fuels, lubricants, plastic, and petrochemicals derived from crude oil are used extensively in manufacturing, packaging, and consumer goods like plastic, synthetic fibers, and household products. These products are central to sectors such as energy, transportation, manufacturing, and agriculture, driving industrial development and enabling modern lifestyle. The video highlights how oil and gas continue to be fundamental to both consumer needs and industrial advancement.